Now that we've created our geometry, we have to create blocks. Blocks contain mesh, and for our simple case, we're only going to need one block. Later, we will discuss how to make multiple blocks and multi-component models. Now, under the blocking tab, the first thing we have available, and the only thing we have available, is create block. Now, we can call this part solid or fluid. If we're working with a fluid within our system, we will leave it a default solid. Now, under a block, we only have one option, which is initialize blocks. Within ICEM CFD, we have to select our geometry where our blocks exist. This creates a bounding block. For our simple geometry, our bounding block will be our block. However, when you have multi-component systems or curved surfaces, we will construct our bounding block, then delete it, and then place the blocks we need. So our type is going to be a 3D bounding box. Now we're going to select all the entities within our model to apply this block. In doing such, we see under our part tree, we have now blocking available, where we have vertices, which if we turn this on, we see little S's associated with our points. We have blocks, which we can show a solid that's existing within our system. Now this block, the vertices are associated with our points by default. Our edges are going to be associated with our lines, and the faces of our block are going to be associated with our surfaces. Now, we have to apply our mesh parameters. So under our blocking tab, if we move to the yellow Rubik's Cube looking icon, we can select mesh parameters and come down to mesh edge spacing. So, the dialog box tells us to select an edge to set our parameters. And to make this a little easier to visualize, we can turn off our curves and surfaces, and we have our block now with associated edges. We can select an edge. The arrow shows the directionality for which the mesh divisions are going to be applied, and the red indicates that our edge is highlighted. Now, there's many methods for applying our mesh law. Biogeometric means we have constant spacing. Biexponential means we can have an exponential increase from both edges. There's many ways you can apply mesh within your system. If you're looking at a fluid domain and you're interested in capturing the boundary layer at the top and bottom of these surfaces, we would apply a biexponential mesh law. But for now, we'll select biogeometric and we'll apply nodes. If we say apply 21 nodes, if we come down and look at our spacing, 21 nodes results in a mesh size of 2.5 centimeters. And we can see the mesh divisions existing on our edge. Now we notice within our block that we have 4 parallel edges. So if we come down a little further, we can copy all these parameters to parallel edges. In doing such, all 4 vertical edges have now been highlighted, and we can click apply. And what we'll do is come up and select our top edges. We'll put 21 divisions, and copy to all parallel edges is already existing. We click apply and OK. Now what we're not going to do is put any mesh parameters in our Z direction. When we take this into CFX as a 3D model, to have it execute as a 2D model, we have to make sure our Z direction has only one block, i.e. one mesh. So once we've put our mesh divisions, we can turn our blocks off and we can click Premesh. We will remesh our out-of-date parts, and Premesh gives you a visualization of what your mesh is going to look like. So right now we have 20 uniform blocks in the X and 20 uniform blocks in the Y direction. Before we actually take this to CFX, we have to convert it to mesh. So under our pre-mesh icon, we can right click and we'll come down to convert to unstructured mesh. In doing such, mesh appears within our parts tree where we have shells and volumes available. This is going to look identical to our pre-mesh because it is a 2D mesh, i.e. we only have 1 unit depth in our z direction. And what we see is on our left-hand side, these cells are colored blue. They're corresponding to our cold side boundary temperature. The ones on the right are colored red, corresponding to a hot side. The ones on top and bottom, the white ones, are corresponding to our adiabatic boundary conditions. And our front and back are corresponding to our symmetry boundary conditions. Now, it's very important to note in our last video that we have to define these surfaces and their names before building our mesh. If we try to do this after the fact, it will not update and CFX will not register our updates. Last but not least, we have to come to output mesh, and under the red toolbox, we'll make sure we select ANSYS CFX. We'll click apply, and then when we write our input file, it's going to ask us to save our project. So first and foremost, we're going to save our project as, and on our desktop, let's create a new folder. And we can call this 2D slab as our project. Now we can output our mesh. It'll ask us to save our project. We have already done such. And our CFX5 output dialog box will come up. It's going to give us a CFX5 file, and we want to make sure we have 5.5 or later selected and double selected. The remainder of our options are fine, and we will click done. Now we have built a mesh for which we can take into ANSYS CFX.